Hey, happy Monday, guys. Again, sorry that we are back to this mode of learning, but we are going to make the best of it and keep going on and get through this states of matter. Again, there are two lessons, Unit 6, Lesson 5, and Lesson 6, that are about states of matter. So we won't have a quiz until the end of Lesson 6. They're shorter lessons, and so you can get through those quickly. If for some reason you did not watch the lesson last Thursday, you need to watch that again. You can find that on the module, and I will make sure that is easily accessible. There are questions with that as well. You will get an email from me tomorrow if you've not completed those. So what I want to do is just start or to review one term before we go on with this lesson. And that is a thing called, let me move this out of the way, the kinetic theory of matter. It's one of our big theories that we're going to need to know. And it is that all atoms are constant and molecules are constantly moving. And it determines the state of matter based on the speed of the particles. So that's kind of the theory, I guess you'd call it, for this whole lesson and the next lesson. Okay. The state of matter depends on how quickly the particles are moving. All right. So now let's just get through this stuff that we saw in the previous PowerPoint. Apologize for that. Okay. Today we want to talk about how the motion of the particles affects the properties. Okay, now remember we've talked a lot about properties: boiling point, freezing point, melting point, all of those things again are properties. Okay, so as you know and as you can read, but I want to go over it with you, ice, liquid water, and steam are all made of water molecules, but they behave differently because of the differences in the kinetic energy, meaning the particles are moving. Okay, so if I can get myself out of there. Okay, so you have ice, you have regular water, and you have steam. Well, they are their state of matter because of how the particles are moving. Okay, so, I should have waited, but that's all right. Which form of water has the greatest amount of energy, kinetic energy? Well, it would be steam, because kind of to simply put it, the temperature's higher. If you boil water, okay, the water goes up to 212 degrees Fahrenheit, which turns it into steam. That's the boiling point. So it has the greatest energy because the particles are moving the fastest. All right. How does particle motion affect we just did that. Sorry, guys. All right. Now let's look here. We're going to look at these three things. Identify substance A, B, and C as a solid, liquid, or gas by placing a letter in each of the small circles below. In the larger circles, draw models of the particles of each substance. So, actually, they're not showing you much here, but let's just look at this. What would the particles in a solid look like? Well, the particles are right next to each other, okay? Shaking a little bit in place. Back to the example from last Thursday, the first PowerPoint, people in a movie theater, kind of moving about but staying in their seats. Okay, don't worry about these letters because they refer to this picture, of which isn't concluded. But this does point to the liquid. Liquid, again, if you remember, like the people in the theater or the lobby of the theater moving around, but there's still other people kind of in their way. You can't get maybe exactly where you want to go. Okay, so that would be a liquid. Then lastly, a gas, the particles are flying all over. Okay, so like people outside of a movie theater. So again, solid, very close together. Liquid, moving some, but not as much as a gas. Okay, what happens when substances change state? All right, so the atoms do not change their identity or the molecules. So in water, it's still H2O, just their speed is either speeding up or slowing down. And that changes the space in the atom. Okay, so this is important to know, really important. Every atom in the universe is moving, no exceptions. The atoms or the molecules in the substance are moving. It might be just a little bit, but they are moving. Okay. When the atoms in a solid begin to gain kinetic energy, so when they start to speed up, they start moving past each other. Okay. And they could possibly change into a new state, not a new substance, just a new state. So we would call that melting. When the particles or the atoms, like in ice, start moving, or the molecules start moving more quickly because they're being heated up, probably. Okay, that is called melting. Now, the other way around, if they lose energy and they start to come closer together, then that would be called, of course, freezing. All right. Many of us associate frozen objects as being cold, but not all objects that are frozen are cold. Now, this is hard and weird, I think, to visualize, but an aluminum can is actually considered frozen aluminum because aluminum does not melt until 1,200 degrees Fahrenheit. Think about that. 1,200 degrees Fahrenheit. And this would be melted aluminum right here. All right, pay special attention to this chart because you are going to be completing one like it for your assignment today. All right, melting. Okay, we have a solid becoming a liquid. I think our best example would be ice cube turning into water. And let's see. Yes. Oh, they said butter in a warm pan. So taking a piece of solid butter, warming it up in a skillet or a pan, and it melts. Okay, how about freezing? A liquid in that case becomes a solid. Think about it for a second. Okay, and they're using the aluminum example again. Aluminum would cool and then turn into what we use for soda cans. Or more simply, water becomes ice. All right, now boiling. Liquid becomes a gas throughout, not just part of it. All of it turns from a liquid to a gas. Something is boiling. Okay? Their example is liquid water boiling into steam, like you were making something in the kitchen. Okay, then there's also evaporation. Okay, and that's when a liquid can become a gas at the liquid surface. Okay, so it doesn't really bubble away. It turns into a gas right at the liquid. So that would be a puddle drying out. Like on Sunday, we had quite a bit of rain. Okay, so all those puddles dried up. That's evaporation. Then there's condensation, which is the opposite. So, like in the clouds, when all of that liquid or all that water vapor turns into a liquid. Okay. Or, for instance, on the side of a glass, if you put ice in it, you'll get water droplets. There's two other words that we haven't talked about at all, and we will start talking about them this week. One is called sublimation, and that's when the liquid state is skipped. A solid goes straight to a gas. It doesn't, like Monopoly, doesn't pass go. It doesn't pass the liquid state. It goes straight from a solid to a gas. Okay. And that's when, like, you have a package of dry ice, or you've seen dry ice and it becomes gas. That would be called sublimation. Then the opposite of that is deposition, and that's when gas goes straight to a solid. Again, doesn't stop at the liquid stage. And that would be when you get frost, like would be getting this time of year on your window. All right, let's look at some real quick questions here. Solids can easily change in volume. Do we think that's true or not? Think of your desk or your kitchen table or wherever you're working today. Can it change in volume easily? Well, no. No, you would have to like cut it up or something. So, no, it's not going to change in volume. All right. What do we think about this? And we're going to work on this several more days this week. Liquids take the shape of their container. Think of soda, pop, whatever you want to call it, in its 2-liter bottle. What if you pour it into the kitchen sink? Is it the same shape that it was? No, because liquids take the shape of their container. So that would be true. And then the last question we're going to look at today, when the distance between gas particles increases, the volume of the gas increases. This is a tougher question. There was a question like this on the pre-test, which we will go over in the next couple days, by the way. All right, that is true. As the particles get further apart, the volume is going to increase. Okay, our exit question for today. What happens to the kinetic energy of the particles of a substance as it changes from liquid to gas? So just think of water if you have to. As it goes from liquid into steam, what happens to the particles? Okay, there's that kinetic theory of matter again. The kinetic energy, the energy of the movement. Kinetic means moving, and we'll get into that in the next unit. The kinetic energy of the particles increases. All right. So that is it. We'll talk more in the daily announcements, but real quickly, I'm not going to do Zoom. I don't think Mr. Decker is either. But if you need to Zoom, if you have any questions, concerns, anything, I will be glad to Zoom. I'm just not setting up a set Zoom. So you just get a hold of me through Canvas, and you guys know that. I hope by now I'll get right back with you. Okay. Have a good day. Okay. We're going to get after it this week.